Hello and welcome. I'm Josh Silverman, and this is Edge Ed, cutting edge education from coast to coast. This lesson, factoring. Let's take a look. All right, so on this very first page here, the page that is numbered page 1, you can see that we have the entire factoring study guide. Now, when I originally created a factoring study guide more than 15 years ago, it was 3 pages long, double spaced. And I gave it out to a group of students. And there was 21 students in the class, and 20 out of the 21 beautiful packets of notes ended up in the garbage can at the end of that class. That's when I realized I needed to change things up. So instead of trying to make it as long and thorough as possible, I went in the opposite direction. And these notes are as tight, as concise as could possibly be. A designer knows they have achieved perfection, not when there is nothing left to add, but when there is nothing left to take away. So this is the factoring notes. Here's how you want to read this. It goes from the left to the right. So it will always go GCF first. Always, always, always GCF first. Do this first, always. The ladder method, that is our technique for finding the GCF. We'll take a look at that in just a moment. Now, after you've gone through, you've checked for the GCF, the next thing we look for is, are there any difference of two squares? Difference of two squares is an absolutely crucial concept in algebra. These are so important that it's not enough to simply know that they exist. You have to be actively looking for them. So you've checked for GCF, you've checked for difference of two squares. That brings us to trinomials. This is your factoring strategy. It goes from the left to the right. We will do this every single time that we factor. Let's do some GCF. All right, so here's what the ladder method looks like. We're going to start off with some expression. We're going to first say, okay, what's something, anything that all 3 of those terms could be divided by? Well, they could all be divided by 4. And so you do that, and it leaves behind this. What can all of those be divided by? They can all be divided by 2. What can all of those be divided by? They can all be divided by A. And then that's it. There is nothing left that these 3 terms can each be divided by except for 1. And so when the question is, what can they all be divided by? And the answer is 1, that means you are done. Let's do a couple. Number 1. What can all 3 of those terms be divided by? Well, they could all be divided by a 7. 3x minus 6y plus 2z. And this is how you write your final form. Whatever you can no longer divide, that goes on the inside with the parentheses. The GCF goes on the outside. Number 2, what can all of these be divided by? Well, they can all be divided by an M. What's left behind? A plus B minus C, and the M goes outside. What can all of these be divided by? Well, all of them could be divided by a 3. So let's start with that. And if we divided each of those by 3, that would leave behind 4m to the 4th n minus 3m to the 3rd n squared minus 2n to the 3rd. What can all of these be divided by? Well, they could all be divided by at least a single n. So when we're asking about the variables, it's the lowest exponent. That's what determines what you can take out. And in this case, the lowest exponent is a 1. You can't see that 1 because it's a hidden 1, but it's a 1 right there. Take out an n. 4m to the fourth minus 3m squared n minus 2n squared. And that's it. You multiply these together. That's what goes on the outside. This stuff goes on the inside. Last one, number 4. What can all of these be divided by? It looks like only a 2. Divide that by 2, 3m squared. Divide that by 2, 6mn. Divide that by 2, 20n squared. Could we take out any more numbers from the front? Could we take out any more from the coefficients? No, because this can't be divided by 3 and that can't be divided by 2. Could we take out an m? No, because that term doesn't have an m in it. Could we take out an n? No. We're done. And that's it. We're going to talk difference of 2 squares. But before we're ready to talk difference of 2 squares, we have to set you up a little bit for that. We got to review a topic called the distributive property. Everyone knows the distributive property. You multiply whatever's on the inside by what's on the outside. Go ahead, take a minute, try the problems on this page, and we'll check them when you're done. Number 1, 2 times x, 2 times 4, 2x plus 8. Number 2, 6 times 3x, 6 times minus 5, and we're done. Number 3, negative 4y. Now, you got to be careful here because this is the number 1 mistake in all of algebra. Failing to distribute the sign to the second term. That is the number 1 mistake in all of algebra. If you're going to get something wrong, that's probably what it's going to be. Negative 4 times positive 3, that's a negative 12. Keep it going. Negative 3 times y, negative 3 times negative 12, positive 36. For the variables, we do it the exact same way. 2x times x, that's 2x squared. 2x times 7, that's minus 14x. 3 terms on the inside, we do it the exact same way. 3x squared plus 9x minus 15. These are still really easy. Number 7, 10x squared minus 80x minus 10. 5p times p to the second, 5p cubed. 5p times 4, 20p. All right, here's where we get to binomial distribution. And this is when we use the technique of FOIL. FOIL is an acronym, and it stands for first. You multiply the 2 first pieces together. Outside. And we multiply the 2 outside pieces together. Inside. And we multiply the 2 inside pieces together. Last. And we multiply the 2 last pieces together. That's what FOIL stands for. First, outside, inside, last. It is an acronym. 7 times 2, that's a 14. In the last step, you'll combine those middle terms. X squared plus 9x plus 14. Number 10, first, outside, inside, last. Combine the middle terms. Oops, that's a minus. First, 2v squared. That's the 2v times the v. Outside, plus 10v. Inside, minus 4v. Last, plus, I lied, last minus 20, and we combine the two on the inside, 2v squared plus 6v minus 20. All right, now these are the ones right here where I want you to pay very special attention. First, outside, inside, last. Now, what happens when we combine those two in the middle? A minus 2x and a plus 2x, they cancel out completely, leaving behind only the x squared minus 4. The middle terms cancel each other out. And after we're done multiplying, we're left with a binomial. There is no x term. There's only the x squared and the constant. Let's see that again in number 13. First, outside, inside, last. What do we get when we combine those two middle terms? Nothing. They cancel right out. What's left behind? N squared minus 49. When we start with the two binomials, we ended up with no middle term, just the squared and the constant. What is special about number 12 and number 13? Why does this canceling out happen? Well, here's why. Because you've got the same two numbers in the last positions, except for they have opposite signs. The same two numbers in the last positions, and they have opposite signs. This brings us to difference of two squares. So all of that page was just to get us to here. All of that distributive property was just to get us to here. Difference of two squares. What is a difference of two squares? This, my friends, is a difference of two squares. This is a difference of two squares. A difference of two squares is what you get if you start with the binomials that have the same number but the opposite signs in the two last positions. And if you multiply them out, it turns into this. A difference of two squares. It's got 1, 2 things. 1, 2. It's got perfect squares. See, both the piece on the left and the piece on the right, we could nicely and neatly take the square root of. What is the square root of x squared? It's x. What is the square root of 4? It's 2. What is the square root of n squared? It's n. What is the square root of 49? It's 7. So you got two things. Both of them are perfect squares, and there's a subtraction between them. Now, when you factor a difference of two squares, you're going to end up with 1 plus and 1 minus. So here's the king idea. This is the big idea. The big idea is that when we go from the two factors into the differences of two squares, what we are doing is multiplying. We're doing the distributive property. We are distributing. But if we start with the difference of two squares and we want to know where it came from, that's factoring. That's factoring. Factoring is the distributive property in reverse. That's what factoring is. It's the distributive property backwards. If we start with the x squared minus 4 and we want to factor that, what does it factor into? X plus 2 x minus 2. The factored form will have 1 plus and 1 minus, 1 minus and 1 plus. It doesn't matter whether you put the plus first and the minus second or the minus first and the plus second. Well, there's 1 plus and there's 1 minus. Let's do a couple problems with distributive property. Now, first, you have to be able to see the perfect squares. All difference of two squares break down like this. Here's our general form. A squared minus b squared is equal to a plus b, a minus b. You're going to take the square root of the thing there, and it goes here and here. You're going to take the square root of the thing there, and it goes here and here. But first, you need to practice finding the square root. I don't see 64. I see 8 squared. I don't see 100. I see 10 squared. I don't see a squared. I see a squared. What times itself is 9x squared? What do you multiply by itself? Well, that is going to be 3x. And you can see that's got to go in parentheses. This will be, the 3x will be the thing that goes here and here. What about x squared, y squared? Same dealio. We're going to put the two pieces on the inside. We're going to put the parentheses, and the squared goes on the outside. Finally, 1, I don't see 1. I see 1 squared. Try these. Give you a minute. Go for it. All right, here we go. It's the square root of the thing on the left. That goes here and here. It's the square root of the thing on the right. That goes here and here. 1 plus, 1 minus. You can see I like to just set up with my parentheses first. We know where we're going with these. It's a C, it's a C. It's a 1, it's a 1. It's a minus, it's a plus. Just changing it up for fun. How about this one? M squared minus N squared. That's going to factor into M plus N, M minus N. Number 5. Now, subtraction is not commutative. The order matters in subtraction. So when we write this out, you're not going to put the y's in the left positions. You're going to put the 5s on the left. You're going to put the y's on the right. And of course, a plus and a minus. So if you were to put the y first and the 5 second, that would be wrong. Don't do that. Same deal here. What's the square root of 400? 20. What's the square root of x squared? X. 1 plus, 1 minus. Number 7. 2x. 2x. 3, 3, 1 minus, 1 plus. And lastly, what is the square root of 25x squared? That's going to be a 5x here and here. What is the square root of 81y squared? That is going to be a 9y here and here, 1 plus and 1 minus. So we start with the GCF always. Then we check for any difference of two squares. Then we're ready to look for the trinomials. Let's talk about trinomials. All right, here's our basic notes. First, start with the signs. If the two signs, here and here, if those two are the same, a plus and a plus, a minus and a minus, scratch that. Let's start with the signs. Check the signs first. If it is a plus plus trinomial, like we see right here, then the factors are plus and plus. We can predict that ahead of time. And so I'll just go ahead and put those in. If it is a minus, if it is a plus minus, then the factors are minus, minus. So if we've got the same signs, it's a sum. If we've got different signs, it's a difference. What would we have to multiply together to get to x squared? That's x and x. What would we have to multiply together to get to 8? All right, this is the point where you just write out your factor pairs, okay? The easiest way to do this, and the step we're on right now is the step that everybody gets stuck on. Don't sit there banging your head against the wall. Go ahead and write out the factor pairs. What are the factor pairs for 8? 1 and 8, 2 and 4. Since these are the same sign, we're looking for a sum. Same sum. Since these are the same sign, we're looking for a sum. Which of those pairs adds up to make a 6? Well, obviously that's 2 and 4, and we are done. Same sign, we're looking for a sum. We know that this is going to be an x and this is going to be an x. The only question now is what goes in these two spots. Write out your factor pairs, 1 and 10, 2 and 5. Which of those can be combined to make an 11? The 1 and the 10. All right. Now, when the first sign in your trinomial is positive and the second sign is negative, like we see here, a plus and a minus, then you're going to get 1 plus and 1 minus for your factors. Those will be different signs. And when we're factoring, we're looking for a difference. Different, difference. Same sum, different, difference. Set it up as we have been doing. We know what's going to go in those first positions, x and x. Since this is a plus minus, it's going to be 1 plus and 1 minus. It doesn't matter which order you put them in. I'm just going to do plus and minus this time. And now we're looking for the factor pairs of 16. 1 and 16, 2 and 8, 4 and 4. We're asking the question, which of those could be subtracted to get a 6? Well, that's the 8 and the 2. And this is my exclusive rule. The heavier sign, not the bigger number, but the heavier one. The heavier sign is, to use a very specific math term, the number with the absolute value that is greater. And since we want to end up with a plus, that's the heavier sign. And so that means the bigger number matches the heavier sign. So the 8 goes with the plus and the 2 goes with the minus. Once again, if it's a minus minus, you're going to have 1 plus and 1 minus. I'll just arbitrarily put the minus first and the plus second this time. X and X. We're looking for the factor pairs of 12. So 1 and 12, 2 and 6, 3 and 4. Which of those could be subtracted to get a 1? Remember, there's a hidden 1 there. That's a minus 1. That's going to be the 3 and the 4. The heavier sign is negative. So the bigger number goes with the negative. The 4 goes with the minus, and the 3 goes with the plus. Try this page, and we'll check them when you're done. Go for it. All right, let's work through these. Here we go. We know how this is going to end up. Couple of sets of parentheses. What goes here and here? That's going to be an X. If it's plus and plus, then it's plus and plus. Factors of 21, 1 and 21, 3 and 7. We want 3 and 7. And look, you can always check. You can always check your answer by FOIL. FOIL is the reverse of factoring. FOIL and factor are in reverse of each other. First, x times x, that's x squared. Outside, x times 7, that's 7x. Inside, 3 times x. Last, 3 times 7. And of course, if we put those two in the middle together, that would give us a 10x. Yes, that's what we started with. That's how you check it. Here we go. Number 2. X plus factors of 100 that add up to 20. We want 10 and 10. Number 3, x. Okay, if it's a minus plus factors into minus. You got to know your sign rules. So that's going to be a minus here and a minus here. Factors of 20, 1 and 20, 2 and 10, 4 and, no, not 4 and 6, 4 and 5. Which of those could be added to make a 12? We want the 2 and the 10. Keep it going. Number 4, x and x. Minus plus, that means the factors are both minuses. So we'll put a minus in here and we'll put a minus in there. What are the factors of 4? Well, we've got 1 and 4. We've got 2 and 2. But which one of those combined to make a 5? That's going to be the 1 and the 4, not the 2 and the 2. Number 5. This time it is a plus minus. So we're going to want 1 of each. 1 plus, 1 minus. X and x. Factors of 12. Oh my gosh, there's my factors of 12 right here. 1 and 12, 2 and 6, 3 and 4. Now this is a difference. They're different signs. So we're looking for a difference. Which of these could be subtracted to give us 4? That's going to be the 2 and the 6. And the heavier number matches the middle sign. So the 6 gets the plus, the 2 gets the minus. Number 6. X and x. It's got to be 1 and 7. We know that. Those are the only factor pairs for 7. Now, since it's a minus, it's 1 plus and 1 minus, and the heavier number matches the middle sign. So 7 matches the middle. So that's the negative, and that's the plus. All right, number 7. This one looks different, doesn't it? What's different about it? Well, we've got a coefficient in front of the x squared term. Usually, when you see that, you think GCF. GCF first, always. Always do this first. Take out the 7 using the ladder method. That's going to leave us an x squared minus a 2x minus a 3. Now, don't forget that 7. We're going to bring that boy down at the end. 2 sets of parens. Minus, that means 1 plus and 1 minus. X and x. And the factor pairs of 3, well, that's just 1 and 3. And we want the bigger number to match the middle sign. And so there's your 3. Now, don't forget, whatever GCF you pulled out at the beginning, that's going to go in the very front in your final answer. So the final factored form is going to look like this. Last one, what's the GCF? We're going to take out a 2. That's going to leave us with x squared minus 5x minus 6, 1 plus, 1 minus, x, and x. The factor pairs of 6 are 1 and 6, 2 and 3, but which of those could be subtracted to give us a 5? That's going to be the 1 and the 6, and the bigger number matches the middle sign, so the 6 goes there and the 1 goes there. Don't forget the 2 out front. One more page to wrap everything up. Try the last page in this packet. I'll give you a minute, and then we'll check them out. All right, factoring. This is all the factoring rules all on one page. Here we go from the top. Number 1, take out the GCF of 5. 5 times x plus 2. That was an easy one. Number 2, no GCF. Is it a difference of 2 squares? Are there 2 things? Yes. Are they both perfect squares? Yes. Is there a minus between them? Yes. This is a difference of 2 squares. Factor it. The square root of that piece is x, and that goes here and here. The square root of that piece is 10, and that goes here and here. 1 plus, 1 minus. Number 3, that's a difference of 2 squares. P plus 7, P minus 7. Number 4, that's a difference of 2 squares. What is the square root of this piece right here? Well, it's not going to be 4c. It's going to be 2c. What's the square root of this piece right here? Well, that's easy. That's a 5. 2c plus 5, 2c minus 5. Number 5, that looks like a difference of 2 squares, but neither of those things is a perfect square. Well, guess what? We've got to take out the GCF first. Take out the 2. That's going to leave behind x squared minus 9. Now, don't forget that 2 that we took up at the beginning. This is a difference of 2 squares. X plus 3, x minus 3 with the 2 in front. So this is an important problem here. Always do GCF first. And sometimes when you do the GCF, what's left behind will be easy to factor. Try the same idea in number 6. Take out the 7. X squared minus 100. We already saw that one. That is x plus 10, x minus 10, and the 7 goes in the front. All right, now we get to trinomials. There's no greatest common factor. It's a plus plus, so we're going to factor that out. Plus and plus, x and x. Factors of 16. 1 and 16, 4 and 4. Well, I've skipped one. 2 and 8, and then 4 and 4. I like to go in order. Which of those can be combined to make a 10? We want the 2 and the 8. Number 8, the first sign is positive. The second sign is negative. When the first sign is positive and the second sign is negative, that's going to be 1 plus and 1 minus. X and X. Plus and minus. Factor pairs of 28. 1 and 28. 2 and 14. 4 and 7. Which of those could be subtracted to make a 3? The 4 and the 7. And the bigger number matches the middle sign. So the plus gets the 7. The minus gets the 4. Number 9. Factor out the GCF. X squared plus 5x minus 6. And that's going to be a plus minus. So that's going to be 1 plus and 1 minus. X and X. Factors that we could subtract to make a 5. That would be 6 and 1. And the middle sign matches the bigger number. Don't forget the 2 that goes out front. Last one. What's the GCF here? 12. Now, maybe you weren't able to see that that was 12 right off the bat. Maybe you just said 2. 6a squared plus 12a minus. Oh, man, I don't know. Can I do that in my head? Let's just go to the calculator. 96 divided by 2, 48. Oh my gosh. And yes, all 3 of those terms can be divided by 6. A squared plus 2a and 48 divided by 6. That's going to be 8. So factor what's left inside, but don't forget these two out here. A and A, 1 plus, 1 minus. The factor pairs of 8, 1 and 8, 2 and 4. Which of those could be combined by subtraction to get a positive 2? That's the 4 and the 2. The 4 goes here. The 2 goes there. Multiply them together. Final answer, 12 times A plus 4 times A minus 2. That's what I've got. Thanks so much for joining me. We'll see you next time. Bye-bye.